Okay, class, let's start. Factors and divisibility. Yesterday we worked on page 205 and we start the page 206. So let's finish page 206 and start working on 207. Now, remember class that a factor is a number that divides evenly the other number. Remember that when you divide, you have one option to find if it is a factor. You divide, and if that division, that quotient, it's a number and it's a whole number and the remainder is 0, you know that it's a factor. So in other words, two numbers that you multiply and you get the product. You get the product, like 5 times 5, it's 25, right? So you know that if you divide 25 by 5, the quotient is 5, remainder 0. So there is a factor. Now, in page 206, yesterday we worked on this, let's review. We say that it's important to know this. When a number is divisible by another number, the quotient is because the quotient, it's a counting number and the remainder is 0. So remember, the remainder must be 0. So we have the chart of divisibility rules. Like in number 2, that means that one number can be divided by 2 if the number is even. Do you remember what is an even number? What is an even number? No? Okay. Remember, even numbers are numbers that they are, like you say in Spanish, números pares, even numbers. Like what? Number 0, number 2, number 4, like number 6, like number 8, like number 10, and you continue the list. Numbers that they can be divided or they are divisible by 2. Yesterday, Joshua was mentioning even and odd numbers. Remember, you learned this in 2nd, 3rd grade. Odd numbers, they are numbers that you say in Spanish, números impares, like 3, number 1, like 3, like 5, like 7, like 9, and so on. Sorry. They are odd numbers, so you need to remember this class. That was in... That is, Rosa, your microphone. That is odd numbers. So even numbers class is what we say that they are divisibles by 2. Like 4, you can divide 4 by 2 and get remainder 0, right? If you divide 4 divided by 2, what is the answer? 4 divided by 2. If you have 4 and you divide it into 2, it's 2, right? Because 2 times 2, it's equal 4, and the remainder is 0. So even numbers. We say that a number is divisible by 3 if the sum of the digits is divisible by 3, by 5 if the last digit is 0, 5, by 6 if the number is even and divisible by 3. So number 6 follows the rule number 2 and number 3. So here we are looking for if number 6 is a factor of 72. So it means that we're going to use this rule. Now, we test if it's divisible by 6 by checking if the number is even. First, we need to check if the number is even. According to this, 72 is an even number. Do you think it's an even number, 72? Look at the number, 72. It ends with number 2, and even numbers, they are like 0, 2, 4, 10, 12. They are pair numbers, like we say in Spanish, números pares. So it's, yes, this is an even number. 72 can be divided by 2 and get remainder 0. If you divide 72 by 2, we can check that, class. We can check that 72, it's a number that it's an even number. Now, what is the sum of the digits of 72? Because that's another way, divisible by 3. A number is divisible by 3 if the sum of the digits is divisible by 3. So we sum the number 7. This is the digit number 1, 7, and the digit number 2, it's 2. Now we add 7 plus 2 equal 9. And I know that in the table of 3, 9, it's there, 3 times 3, right? So the sum of the digits is divisible by 3? Yes, it is. Yes, it is divisible. Why is it divisible? Remember that in the table of 3, I can find 9. So I can divide this number and get remainder 0. So 72 is divisible by 6, we say here. So 6 is a factor of 72. In this way, we can identify that it's a factor of 72. That was of yesterday. Now, let's continue with the second part. We need to complete the table using the same exercise. Factors of 72. Okay, factors of 72, what we're going to do? What we're going to do, class? We're going to identify all the factors that this number has. For example, 1 times 72 equals 72. So the factors, remember that two numbers that I multiply is 1 and 72. So they are factors. Let's find out more factors. How can I find another factor? Let's try, let's see here. This, it must be 72. All these answer must be 72, class. So let's write this. 72. Here must be 72, the answer. So I need to look for two numbers that you multiply and get 72. Two different numbers, class. Think about two different numbers that they might be factors. For example, let's see number 2. Can we multiply 2 by one number to get 72?
No. 8 times 9. 7.
8 times 9, 72. That's right. I'm going to write that one there here. 8 times 9 equals 72. Perfect. 2.
And 9 times 8 equals
9 times 8 is the same. Yes, here is the same. So the factors are 8 and 9 because 8 times 9 is 72. Now, a number multiplies by 2 that is 72. Yes, we can have it. How can we identify this? Let's divide 2. 72 divided by 2. We can use this division to find it out. Can we divide it and get remainder 0? Now, remember, we use the first digit that it's 7. 7 divided by 2, class. 7 divided by 2.
12.
No. 7. Look at the table of 2. One number that you multiply by 2. And the answer is 7.
And
2 times? 2 times 3, class. 2 times 3 equals 6. Now we subtract 7 minus 6.
1.
1. Okay, and now you put down the next digit that it's number 2. And you say 12. 12 divided by 2, class. In the table of 2, look for one number that you multiply by 2. Okay, excellent, Gabriela. 2 times 6 is equal to 12. So I subtract 12 minus 12. 0. I don't have more digits. And you see, this number is divisible because the remainder is 0. Remember, that is the rule. A number must be divisible by another number if the remainder is 0. In this case, it's 0. So 2 times 36, okay, using the same color, 2 times 36, it's equal 72. If you multiply 2 times 36, you're going to get 72, class. So the factors here are number 2 and 36. Yes? Now, let's see, with number 3, can we divide 72 by 3 and get remainder 0? What do you think? Yes, we can try. We can try. So let's do it. 2, sorry, it's 3. And here's 72 because we are dividing 72 divided by 3. Now, 7 divided by 3. We use the first digit, it's 7. 7 divided by 3. 3 times 2, that's right. 3 times 2 is equal
6.
6. So I subtract 7 minus 6 equal 1. I put down the next digit, that is number 2. So I have 12 now. 12 divided by 3?
4.
4.
12.
Excellent. And equal 12. So 12 minus 12?
0.
0. My remainder is 0. So it means that 12 is divisible. It's one of the factors of 72 because 3 times 24 it's equal 72. So my factors are here 3 and 24. So you write here 3 and 24 as the factors. Now, can we divide 72 by 4 and get remainder 0? Yes. Let's find it out now. We are checking here using the division. So let's divide 72 by 4. And it says 7 divided by 4, class.
4 times 1.
4 times 1, yes. And it's 4. And 7 minus 4?
3.
3, excellent. Now we put down the next digit, that it's number 2. And we have 32. 32 divided by 4?
8.
8, excellent. 8 times 4?
32.
32. So 32 minus 32 equals 0. My
0.
remainder is 0. So it means that I can use this 18. So 4 times 18 equals 72. It means that the factors, the two numbers that I use, it's 4 and 18. They are the factors of 72. Okay, perfect. Now, by 5, do you think that we can multiply by 5, divide 72 by 5 and get remainder 0? No, we cannot. We can divide it, but we're going to check that remainder. It's that we are going to have remainder. A factor, a 72, it's not divisible by 5 because the rule says, it says the rule. I'm going to read it for you. The last digit is 0 or 5. That is a number divisible by 5 if the last digit is 0 or 5. What is the last digit of 72?
2.
2. It's not 0, it's not 5, so we cannot use number 5. Now, by 6, yes, by 6 we can try. By 6 we can try because this follows the rule number 2 and number 3, so we can divide 72 divided by 6. Let's check here. What is the answer of this? Of this division? 7 divided by 6.
42.
42, that's right. 42, why 42?
7 divided by 6. No.
1.
1.
Because 6 times 1. 6.
6.
I subtract.
1.
1. And I put down the next digit, that it's number 2. 12 divided by 6.
2.
2, excellent. And 2 times 6 equal to
12.
12. 12 minus 12.
12. 0. 0. 0. Sorry.
Excellent. My reminder is 0. Thank you, Gabriela. Good job. So it's 12, the number that I multiply by 6 to get to 72. So my factors are 6 and 12. 6 and 12. Here my factors are 6 and 12, class. So as you can notice, we have factors. We have many factors for 72. A number can have 2 factors, 1 pair of factors, or it can have more. In this case, we have 1 pair, 2 pairs, 3, 4, 5, 6 pairs of factors. This number, it has all of these factors, 72. Now, how did you check if 7 is a factor of 72? Do you think the 7 is factors of 72, class? We can check. So let's divide. Let's divide here. 7. Okay, let's use this space. 7 and the 72 because it's the number that we're dividing. So let's divide 72 divided by 7. 7 can be divided by 7.
Yes.
7 times 1.
7.
7. So let's do it here. 7 times 1, it's 7. So 7 minus 7,
0.
0. And now we put down the next digit, that it's number 2. 2 can be divided by 7?
No.
No, so we put a 0 and we say 7 times 0,
0.
0. And 2 minus 0,
2.
2. And this is what?
A reminder.
Reminder. Now, it's 7 a factors of 72?
Yeah.
Yes?
No.
No. Excellent. Why not?
Because
it's
it's a reminder.
Excellent.
Excellent. The reminder 0.
Perfect. Good job. Thank you, Gabriela. Thank you, Joshua. Why it's not 7? It's not a factor 72. As Joshua says, he has reminder. The reminder is 2. So remember, a number is divisible by another number and it can be a factor. Is the reminder, it's 0. Like this case is, look here, the divisions.
We have to copy the 7.
Yes, you can copy the division. So
Adentro del cuadro and show your work or no?
if you have a space, yes. If you have a space, you can do it. It's okay. Now, here we write the answer. How do you check? Okay, by dividing. By dividing. Okay, let's write here, 72. And we say that there is a reminder. There is a reminder. So it's not a factor. Let's write just that. Seven. It's a factor of 72. Want me to finish to here, copy, and you ask me if you have any question.
I finished.
Okay. Okay, Sian.
I finished.
Okay. So we can identify if a number is a factor of divisible by dividing. You can divide like we did here to get reminder 0, and you check that it's a factor 36, because if you divide 72 by 2, you get 36 on the quotient and reminder 0. But also you can look, sometimes you just look for the divisibility rules that it's on the chart in the same page, and you can identify if it's divisible or not. And next page, 207, we're going to practice more. We have more exercises to identify if they are factors or not. So can I change the slide, class? Did you finish? All of you finished?
Yes.
Yes. Mia Valentina, Alberto, you finished? Yes. Santiago Chavez. Did you finish, Santiago Chavez? Yes or no?
I finished.
Okay, Gabriela.
I finished, Miss.
Dani, Santiago Hernández, Camila. Your
Yes,
video,
Miss, I finished.
your video
Finished.
finished. Okay, now let's review. Let's review one more time the rules because in next page we're going to use these rules. Now, a number is divisible by 2. One number is divisible by 2 if the last digit is even. Remember, an even number, they are not numbers 2, 0, 2, 4, 6, or 8, 10, and so on, right? These are even numbers, like 2 if the last digit is even. For example, look at this number, 3,978. The last digit, look at the last digit, it's number 8. 8 is an even number. So yes, this number is divisible. But what happened with this amount, 4,975? The last digit is number 5. 5 is not an even number. You don't see an even number that is included 5 as an example, no, right? So it's not divisible by 2. Just by seeing the number, we're not dividing. We're not going to divide now. Just use the rules to identify because dividing takes too much time. So just using the rules, you see, oh, the last digit is 5. So it's not divisible by 2. It's not divisible by 2 because it ends with in 5. A number is divisible by 3 if the sum of the digits is divisible by 3. So if you add, for example, 315, what happens if you add these digits? What are the digits? 3 plus 1 plus 5. What is the answer of this addition, class? 3 plus 1 plus 5.
9.
9. 9 is on the table of 3?
Yes.
Yes.
3 times 3.
3 times 3. So this amount, these digits, 3 plus 1 plus 5 is 315. Yes, it's divisible. But what happened 139? You add 1 plus 3 plus 9. What is the answer of this addition?
9.
9 equals 13.
13, excellent. 1 plus 3 plus 9 equals 13. 13, it's on the table of 3?
No.
No, 12, yes, but 13, no. So this number is not divisible for that reason. You check if a number is divisible by adding the digits. By adding the digits, class. 3 plus 1 plus 5. If here the answer is 9, so it's divisible by 3. 1 plus 3 plus 9 is 13, so it's not on the table of 3, so it's not divisible. What happened with number 4 when a number is divisible by 4? If the last 2 digits form a number divisible by 4, like this, 8,512. You see, the last 2 digits, it's 12. 12 is in the table of 4, right? 12 is in the table of 4, so it's divisible by 4. But 7,518, the last digits are 18. 18 is not in the table of 4. Excellent. When a number is divisible by 5, this is easy by 5 because you just check if it's 0 or 5 like this. What is the last digit?
5.
5. So it's divisible by 5. And what is the last digit?
8.
8 it's not. What happens if I tell you this number, for example? Is divisible by 5, yes or no?
Yes.
Yes. You see, it ends with 0. If I tell you this one? Yes. If I tell you this number is divisible by 5? No, because it ends with 6 and it says it must ends with 5 or 0. By 6, if the number is divisible by 2 and 3, so by 6, it's using the rule number 2 and rule number 3. So that number must be an even number. 48. 48 is an even number? Yes, look here. It's an even number, 48. And 48, if you add the digits, is divisible by 3? So we add, we check. 4 plus 8, class, what is the answer of 4 plus 8? 12. 12 is in the table of 3? Yes. It's in the table of 6? Yes, it's on the table of 6 and 3, so it's divisible. But what happened with 20? 20 is an even number. But if you add the digits 2 plus 0, what is the answer of 2 plus 0?
2.
2. And 2 is on the table of 3?
No.
No. 2 is on the table of 6?
No.
No, so it's not a divisible number by 6 for that reason. What about number 9? If the sum of the digits is divisible by 9. This is like rule number 3 that you need to add. 711, you check your answer by adding 7 plus 1 plus 1. What is the answer of this addition?
8. 9.
9. And 9, it's on the table of 9?
Yes.
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 Now,
That is the table.
yes, 93. You add 9 plus 3. What is the answer of this addition?
12.
12 is on the table of 9?
No.
No, it's not on the table of 9, so it's not divisible for that reason, this number. And 10, the 10 is another one that is easy. Is that divisible by 10 if the last digit is 0, like this number? Look here, it's 0. This number is 6, so it's not divisible by 10. Yes?
Yes.
Now, using this information, okay, we are going to work on this. With this, we're going to finish class. 4 is a factor of 28. So we are going to identify, yes or no. Using the rule, 28. 28 is a factor of 4. Is 28 on the table of 4? So we're going to, yes, it's on the table. So it's, yes, it's a factor. So we can create here 1, 2, 3, and 4. Okay, here the rows. 4 times what? Which numbers you multiply to get 28 in the table of 4? 4 times 7. That's right. So we say 4 times 7. So we have 1, 2, 3, 4, 5, 6, 7. So we can create a chart here. And we know that here we have 28. So 4 times 7 is equal. I have 4 here and I have 7 here. Equal to 28. 4 times 7 is 28. So yes, 4 is a factor of 28. That is the answer, class. With this, we're finished. Yes? Okay, the next exercises tomorrow, we're going to continue. The next class of math, we're going to continue because we don't have time. So let's finish here, class. Let's finish with this exercise. Bye-bye. See you later.
I finished with
Okay, thank you, Rebecca. Thank you. Bye-bye. See you next class.
I finished me.
Okay, bye-bye, Gabriela. Thank you, Kaler. Bye-bye, bye-bye.
Bye-bye.